I guess it's a minute early. That's okay. Well, I wanted to ask what we're going to do today. We're doing a review. Let's just go over the first two tests. At least, well, 10 questions. I took the questions that people did the worst on, and I was going to solve them for you, see if there's any questions. I don't know. Well, that's what I plan to do on Monday. Of course, we had a snow day, or whatever you want to call it, natural disaster. This actually isn't the worst natural disaster I've had to deal with here. About 4 years ago, Kilauea volcano went off. I was teaching at Hawaii CC online at the time, and like I had students that were having magma going through their homes, and they had to go to the dorms and UH Hilo to be sheltered, and we got them through that. And there was an earthquake during one of the tests. I was when I did tests and testing. I don't do tests and testing centers anymore. Who's calling me? It's my sister. She can talk to me later. But anyways, yeah, we got all them sorted. So we'll get you guys sorted. I know that that Sunday night and Monday was a pain in the butt. But I guess everyone's has power, at least if you're on here. So did you lose power? You're in Lahaina, right?
Yeah. No, we're fine.
Yeah, I didn't lose power. I didn't lose water. So some people up country lost power for like 2 days.
Yeah.
And Kihei's pretty messed up.
Really?
Oh yeah, Kihei's. At least it's like a disaster area there. It's like, especially Lower Kihei Road, just covered in mud.
Huh.
Gonna drive all the way there. But okay, but I wanted to show you something real fast. Where is it? Oh, it doesn't want to move. There we go. Oh, come on.
The rainbow, yeah.
There we go. Oh, there's a cool interactive graphic. Oh, it's not showing up on here. Why aren't you showing up? Let's show the graphics. Oh man, it is not showing the graphics. Chemical and engineering news, you failed me.
Refresh.
I can try refreshing. Let me see if I can get on my iPad. No, it shows you the different mutations of the. It's something I can't really send you guys unless you're a member of the American Chemical Society.
Is it the Wi-Fi blocking?
I think it's resolution.
Is that okay?
That's fine. Yeah. Is that your actual card?
Yeah, I can log into the app if you want.
Oh, no. Doesn't matter.
Is there anything that Southburg episodes in becoming true?
I might as well. Sorry, guys. Okay, here we go. I thought it was pretty cool how they have this. So this is the original spike, and these twirly things. This is a structure known as an alpha helix. Are you guys familiar with protein structure? I'm guessing probably not. Yeah, well, DNA is a beta helix. This is an alpha, and hair is almost all alpha helix. And this right here, you see that's known as a beta sheet. So silk is almost all beta sheet. It's just ways that you have, this is the rest of the protein strands. So, and so we look at the different variants, and here is alpha. Oh, is it? Here we go. So the alpha variant, United Kingdom, and the alpha variant was the dominant variant in the United States. Well, there's a primary strain. The United States, the history that we had, it was the primary strain that was alpha, and now it's delta is the primary strain. And these are the points along the spike protein where there's mutations. And it actually made this alpha variant is more virulent. You can see it's 50 to 70% more infectious. If you can, can you read that, or is it too fuzzy? Okay. So, and doesn't really do that much. So this one's fine. All our treatments, vaccines work very well against it. And a little more scary was the beta variant, came out of South Africa. And because the beta variant is more resistant to vaccination. So the alpha variant pretty much fits well with our vaccine arsenal. The beta variant, though, is a little less, our vaccines don't work as well against it. And especially, well, if I can be so patriotic, America has the best vaccines. So we anticipated actually mutations to happen up here. So we looked at the mutations up there and we anticipated some of them. So we formulated our vaccines to work for the top of the spike there. And it was a gamble and it paid off. So well, at least the vaccines are the Johnson & Johnson BioNTech, which is actually a German company, but we call it the Pfizer vaccine. Pfizer just took their technology and then scaled it up. So Pfizer actually didn't make it, they partnered. So although we say Pfizer vaccine because it's an American company, it's really everyone else calls it the BNT or BioNTech. And Moderna, my favorite, of course. And Moderna, all three of those had the attributed, looked at the spike. The other one, Moderna, added scaffolding inside of the spike, so that way it stays open. Because if you take it off of the virus, it kind of shrinks. So they kept it open. So in my opinion, the Moderna vaccine is going to work better against variants than the rest. That's my own opinion. So that's a beta, a little scary. It didn't really take hold in the United States. Of course, so here's epsilon. We don't care anymore. Didn't really do that much. So, I mean, even there's a variant, it looks like, they don't take hold. So see the reason why it doesn't take hold, this one's 20% more infectious. So it's the ones that are more infectious are the ones that take over. And let's see what else. So gamma also didn't really take hold. So, but isn't this cool though, that you can see here, and we know down to the molecule, where this thing has mutated. I mean, this is like science fiction to me. The fact that our science and technology is so good that we can track these things molecule by molecule. I think it's amazing. I think it's absolutely amazing. And, you can see and we can relate it to the previous variants. And here's Delta, of course, the one that's prominent now. And it is much so. So here's the problem with Delta, though. You can see lab experiments shown that the variant gets into cells more easily. Let me do here better. So more easily and effectively once there. So epidemiological studies have found that it is more transmittable than alpha. As a consequence, has become the dominant variant. So it's the dominant variant in the United States. So attributes to about 99% of the cases in the States. I think Hawaii too. So, and the good news about Delta though, the vaccines respond very well to it. So vaccines are fine, and also the therapeutics. So the Regeneron cocktail, the infusion cocktail, that works really well against this variant. So it can be prevented, and it can be treated very easily. So good news. And here's another one, iota. We don't really know what's going on here with iota. And Omicron, of course, this is the one that we're worried about currently. And part of it is we just don't know. We don't know what's going on with this one. If it's more virulent, the general rule seems to be that if the variants are more virulent, then they'll take hold. There was some concern with this one because there were in Hong Kong, there were 2 people that were fully vaccinated being quarantined opposite each other and like in the same hotel, and one managed to infect the other, and I think they were fully vaccinated too. So, and that they were worried like, oh, is it gonna be that virulent, or was it just a chance occurring? And the truth of the matter is we don't know. Right now though, like the word on the street, if you will, if it looks like it's not that big of a deal. It looks like it's that it may not be as virulent. It might be virulent, but it may not be as virulent as they're worried it will be. Because if you remember, there was also lambda and mu. You remember those variants? Those ended up not taking hold. And lambda and mu were concerning because they in the lab, they put the antibodies like the COVID antibodies into see how they respond with the different viruses, and lambda and mu seem to be relatively resistant. So, and we don't have the data yet for Omicron. We also don't know its real life transmittability yet. So, but it looks like the symptoms are milder. So that's hard to say. So I myself, I'm actually not very concerned. If you're, well, I mean, I'm also triple vaccinated. So, I mean, I'm approaching my peak immunity. So I got vaccinated on the 28th of October. That means that you kind of reach your peak immunity after 2 months and it starts to fade. So like basically the next 3 months, I'm invincible. So, I mean, I'm not really concerned, and I'm traveling for Christmas. So yeah, question.
After that, do you have to get another vaccine to build up your immunity?
Well, I mean, we don't know a lot of things about this because, I mean, the mRNA vaccines are new technology, so we don't know how much the immunity is going to fade over time. I mean, there's like you can check to see how many antibodies you have. That's one way of doing it. And generally speaking, like Moderna, people had about 40 times more antibodies than Pfizer, for instance. So you could, I mean, after 6 months, you could track it down. So where Moderna was about 75-ish% effective, and Pfizer was 45-ish% effective against preventing mild and moderate cases. So, but I mean, the data for prevention is done in real life. I mean, you just have to track people and then compare them to a control. And so, I mean, and then see who's gotten more and more sick. Here in Hawaii, we have someone that had the Omicron variant, and he was unvaccinated, but he had the disease naturally a year ago. So, but of course, I mean, like all diseases, your immunity fades, and we don't know how he's doing.
Because it mutates, right?
Well, your body just is no longer on high alert. I mean, like right now, I mean, so, I mean, I got the flu vaccine in August, and my immunity is starting to fade for that. So, which I don't know if that was a smart move or a dumb move. Peak flu season is January to March. So maybe it'd been better if I had gotten vaccinated in October. So, or in November, because then I would reach the peak of my immunity. But the flu vaccine is not terribly effective. It's like 40-ish% effective.
Right.
So, but yeah, it mutates, and your body just, I mean, over time, it just, your body just doesn't, it's not always just super ready to fight something off. I mean, some vaccines last forever. Hepatitis A and B do. So, for instance, I mean, unless you wipe out your immune system, like if you get measles, it'll wipe out your immune system. Or if you get a bone marrow transplant, when they kill your bone marrow, kills all your immunity. So then you have to get revaccinated, but pretty much some things just go for life. So Hep A is 2 shots, Hep B is 3. So, and I mean, so I know I'm just kind of, I know I'm dancing around the issue by telling you stuff that I'm like, I'm going for partial credit here, you know, as a test question. I mean, like, because I mean, the short answer is we don't know, and probably. And the CEO of Moderna he thinks that that his vaccine won't work well against Omicron. So he thinks there'll be a lot of breakthroughs with the Moderna vaccine. So, and they say they're formulating, they probably already have it. I mean, Moderna made the COVID original strain vaccine in 2 days. So, and they already have it for the alpha and the beta variants and several others. They're just playing around with it. So they probably already formulated it for the for Omicron. They just haven't, you know, done anything yet. I haven't looked at their press releases. Like I said, part is that I'm not really that concerned. Also, besides the vaccines, we're going to have the oral therapeutics soon. So I mean, Pfizer already started making their pill, and hasn't been FDA approved yet, but they've already started manufacturing it and they're ready to distribute it. And the Merck, well, the FDA voted in favor of emergency approval, but the Pfizer drug works better. It's more effective. The Merck, well, the nice thing about the Merck drug is that basically nothing's going to mutate around it. I mean, at least no coronavirus is going to be able to, get a mutate around the effectiveness of that drug. The protease inhibitor that will. Do you want to know how they work, or does that interest you guys at all, or you don't care?
The drug?
Yeah.
Sure.
Yeah, the Pfizer drug. So, well, let's talk about viruses. Viruses are basically a protein coat, and you know, of course, here's the spike. So they're a protein coat surrounded by nucleic acids, either DNA or RNA. So the viruses that have RNA in them are known as retroviruses. So HIV, herpes is a bunch of ones. So smallpox is a herpes virus. So is herpes 1 and 2. So oral herpes is 1, genital herpes is 2. Chickenpox, that's a herpes virus. Those are retroviruses, and also, of course, COVID is a retrovirus. And so, I mean, we mentioned about cells, that cells are phospholipid bilayers, but there's other channels in cells, and there's holes in there's the channels in the holes in the cell membranes, and what happens for viruses is they fit in that hole. So this is the thing that sticks into the hole for our cells, and then the virus is able to enter a cell and takes it over, and then turns the cell into a virus making factory. So the way that the viruses do this is, I mean, essentially what we call gene therapy. When the virus enters into the cell, it then loses its protein coat, and then the nucleic acids go and they mutate the host cell's nucleus, and it turns the host cell then into a virus making factory. So the way that COVID works in its life cycle is that there's RNA in the inside of the virus, and there's a step in there that the RNA is transcribed to another RNA. And then I think that it's transcribed to DNA. I'm not exactly sure, but I know that there's a step in the life cycle of COVID, of coronaviruses in general, that RNA is converted to RNA, because they have the complementary. Are you familiar with that? Like, so guanine and cytosine, for instance, are complementary, and adenine and uracil, so thiamine for DNA, uracil for RNA. So, and the way that the Merck drug works is that it mutates. So when you have that RNA to RNA step, it just mutates the heck out of the code. So when it mutates, and usually mutations, you think mutation like, oh, we're gonna make cancer, and you're be Teenage Mutant Ninja Turtles, you know, you're mutated. Most of the time, mutations, generally speaking, are bad. So cancer and other, like cancer is almost like one of the causes of cancer is actually bad luck. I mean, there's mutations and it's an unfortunate mutation and you happen to get cancer kind of thing. Usually mutations means loss of function. And that's how the Merck drug works. Just basically mutates the virus so quickly it just doesn't work anymore. So, and okay, so then go back to the RNA, and COVID then takes over the cell's nucleus, turns it into a virus making factory. And so what it directs your body to do, or your cells to do, is make so remember, a virus is DNA or RNA, in this case RNA surrounded by protein, makes this really, really long strand of RNA. And imagine like a really long ribbon. And then you have this long ribbon, and there's an enzyme called protease. It's like a circle. It's like literally like a disc. And then the ribbon fits into the disc and it clips it. So it's like clip, and it's like runs a ribbon, clips it, keeps on rubbing another ribbon, clips it at the end. And then the strands of RNA then get surrounded by protein. Enough of the viruses fill the cell bursts, and all the viruses leave. So of course, the way antibodies work is that it just fits over this spike. So it fits over the spike. So you have the spike, antibodies come, they fit over the spike. Now the spike cannot go into the channels inside the cell. That's part of our adaptive immune system. Yeah.
So the drug mutates the protein or the virus itself?
It mutates, it changes the RNA to RNA transcription.
Okay.
So whenever there is a step that RNA converts to RNA for any life form, the Merck drug just mutates the heck out of it. And
Could it become drug resistant?
in my opinion, no. It's going to be very different. It's just because of the life cycle. Some things you just can't become resistant to. I mean, humans, for instance, will never be resistant to sharp objects, right? I mean, like you say, like, I mean, I remember I was grading a science fair one time, and a student was saying, like, I can make super bugs that are resistant to alcohol. So I can take alcohol, it'll kill 99.9% of them. And I take what's left, then I grow it, and I add it with alcohol again. Eventually they become resistant to alcohol. I'm like, yeah, no, not really. Some things just kill. So humans will always be vulnerable to bullets. So, I mean, like, if we have a group of people and we just open a machine gun, like we have the Squid Games, and we shoot a bunch of people, and then we let them reproduce and come back, and then we take and shoot a bunch of people, and are humans going to evolve to the point in time that we are not affected by bullets? And the answer is no, right? So if all we have to eat are peanuts, and the people with all the peanut allergies die, and then the next generations, if maybe a few more die, can you get humans completely adapted to peanuts? Yes, you can. Bullets, no, right? So in my opinion, this drug, because of the life cycle of the virus and how it works, it's just not ever going to be, nothing's going to be able to, no coronavirus is going to be able to evolve around it, which is a big medical breakthrough. Because usually antivirals, they're very virus specific. So the Pfizer drug, yes, it can evolve around that. We have the HIV drug that works out. Actually, there's an HIV drug in the Pfizer drug is two drugs. It's a COVID drug and an HIV drug mixed together. And they have, well, yeah. But what was I going to say? But yeah, I mean, but the Pfizer drug is also it works so well. It works better than the Merck drug, actually. So, but once we can start treating this at home, I mean, I like to think, I hope the pandemic's gonna be over, right? We have the vaccines, and that's the biggest battle, and then we have therapeutics right now, but you have to go to a hospital or a clinic to get them because they're intravenous. Now since we have oral meds, and once they're distributed, right, you test positive, what do? You hang out at home for 5 days and they take pills, and you watch your Price is Right and your blanket for it, and you're fine.
How much was this drug pill?
$20.
What's that?
That I was thinking too.
Oh, okay. The drugs are a lot more expensive than that. I think it's gonna be like $1,000 for a course.
Well, one pill.
Oh, for one pill? No, it'll be like,
At least
I mean,
100.
yeah, at least 100, yeah.
Yeah,
Yeah, it's gonna be ridiculously expensive.
yeah. Like the boxes of the test, isn't it like $200 and get 20, because each one's 5?
I think I calculated down to the ones that I have.
And you get those expired ones.
Yeah, they're $5 a piece.
Yeah. People, some places are charging like $90 for a test.
I think it's like even 200. I think the one by Whole Foods. Yeah, I mean, I
That's-
told my neighbors, I'm like, hey, you want to test it? I can test you. So, and the rapid test isn't even an official test. It's the
Really?
PCR. Yeah. Well, I guess it depends on the,
That's the antigen, right?
yeah, the way the test works, actually, it looks for the spikes.
Yeah.
And you have the antibodies, you have the antibody in the thing, and it's a spike, and then you have the 2 lines. The first line is control, it's actually chicken guts. And the second line is the spike antibody complex. So, but the PCR test, they look for the RNA. It's testing for the RNA that's inside the virus itself.
That one takes a day.
It takes about 20 minutes, but it's like you have to wait in line. To do the actual PCR, the polymerase chain reaction, they use that a lot for like crime scenes. So like, I mean, like if you find blood, for instance, and you want to DNA sequence it, the polymerase chain reaction, you just duplicate the DNA or RNA many times, and you get a small sample, you get a huge sample. Of course, every time you duplicate it, you can get error. So, but you get a huge sample, and that's also like they got to be careful with those, because I mean, like if you can go beyond what's identifiable if you do too often, or too many replications. Oh, and the drugs, unfortunately the Merck drug will not work against HIV, because HIV, and it doesn't work against us. So we have DNA to RNA. So in our cells, we've studied that our DNA unzips and then messenger RNA forms over the DNA, and then that causes protein synthesis. So the HIV does RNA to DNA. That's how they take over the cells. And so it doesn't affect them. It doesn't affect us, doesn't affect HIV. So this is not an antiviral that works for all viruses. So just the ones that have RNA to RNA transcription, unfortunately. But then again, if we had something if you took something that dealt with RNA to, I guess it would be RNA specifically to DNA. If it was DNA to RNA, it would kill us, because we wouldn't be able to make any proteins and we die in like a couple days. But yeah, anyways, that's one thing about drugs, is you have to weigh the risk versus the rewards, and then worry about, is this going to cause more harm than good? And I wonder about the antivirals. I don't know what the side effects are going to be. Like a lot of people that take it, I don't have HIV, but I have friends that are HIV positive, and they say that they're cocktail drugs. It makes them, give them weird dreams and stuff. It's very common. So I wonder if that's what's going to happen to people that take these drugs. I don't know, because especially the Pfizer drugs, that's an HIV drug. But other questions? Sorry for the aside there. Okay, I guess we're going to go back to chemistry. Anybody have what?
That is good.
Yeah, well, it's not what we have tested on. There's 2 days gone. Yep. Anybody have any questions about the final before I start? It's 50 questions, all multiple choice, no short answer. On the website, yeah, on mastering. Are you guys able to sign on now? Okay.
I am,
Could you not before?
no, I was on.
Yeah, I was always able to as well. I don't know if it's because I don't know if it was a hardware issue or, but apparently a lot of students are having that and a lot of people were freaking out. So that's why.
A whole molecule?
What? Oh, this one? Yeah, that's cocaine.
Oh, wow.
So going all the way back to test one, how about you guys, Zoomers? Actually, do you guys have any questions on the test?
Like the other ones, right? Just more questions.
I'm sorry, I didn't quite catch that.
Just like the other tests, just more questions.
Yeah, but it's all multiple choice. It's not short answer. Like the other tests have 5 short answers typically. Like 20 questions,
Oh.
multiple choice, and 5 short answer. This one just has 50 multiple choice. And it's
Okay.
comprehensive. So, other questions? Okay. So atoms in 35 milligrams of cocaine. So how do you do this? So first of all, well, count up the atoms. So 17 carbon plus 22 hydrogen plus 1 chlorine plus 1 nitrogen plus 4 oxygen. So what is that? That's going to be 39, 40, 45 atoms. I'm always afraid I'm going to make some stupid mistake. Is that? Look at my cheat sheet. So, yep, 45. Next thing we gotta do is get the molecular weight of cocaine. So it's going to be 12.01 times 17. That's likely 17. So, and where am I getting this from? I'm getting this from the periodic table. So here is carbon. You can see that's 12.01. And then 17 because 17 atoms there, plus 1.008 times 22 for hydrogen, plus 35.45 for chlorine, plus 14.01 for nitrogen, plus 16.00 times 4 for oxygen. And if you do that, you get 339.8 units are gram per mole. So you would do 23.5 milligrams times gram to 1,000 milligrams. I would just personally, I'd write this as 0.0235 grams, but I'll write it out properly each step. So then mole cocaine over 339.8 grams cocaine, then 6.02 times 10 to the 23rd. Let's see, molecules per mole. I'll put cocaine. How do you? I don't know how I'll put. So times, then you have 45 atoms per molecule for cocaine. And you do all of that and you get 1.87 times 10 to the 21st atoms. Okay, so you see that atoms in 23.5 milligrams of cocaine. So first thing you do, count up the atoms, and there's 45 atoms in every molecule of cocaine. And then you calculate the molecular weight, and it's 339.8. You take each element, multiply it by the number of each atom in the molecule, and then you do dimensional analysis. So milligrams cancel, grams cancel, moles cancel, molecules cancel, and you get atoms. So, questions with this one? Of course, it's always like, it's so easy. Why did I get that wrong? God. Okay. So phosphorus reacts with chlorine, this equation. The mixture contains 45.59 grams of P4 and 130.5 grams of chlorine. So how much mass of the excess reactant is left? So this is a limiting reagent problem. So what we start off with, so let's do the molecular weight. Chlorine, this is going to be 2 times 35.45, 70.9 grams. So phosphorus is 31 grams.
Seeing it on the
31 times 4, so that's 124 gram per mole. Okay. So we
people
got to
can
figure
see
out
the-
which one's the linear.
Are you
Someone's,
trying to share the screen? 'Cause
oh,
we're
is it
them that
not,
we're
it's
seeing
not
you.
working? Oh, did I not share the screen? Oh God, I didn't. Oh, you saw, oh, I'm sorry.
There we go.
Oh, so you didn't hear me talk about the COVID virus at all?
Oh, it was showing in the back, but I just thought you put it.
Oh, that's weird. Okay. Anyways. Oh, sorry about that. Nothing like to do the last day with a goof. All right, anyways, tetraphosphorus is 124 grams per mole. Dichlorine is 70.9 grams per mole. So limiting reagent problem. So let's start with phosphorus. 45.59 grams phosphorus. So mole phosphorus over 124 grams. And then we have 4 mole PCl3 to every mole P4. And I'm getting that from that relationship there. Okay. And then I also do the same thing for chlorine. 130.5 grams chlorine, mole Cl2 to 70.9 grams. And then it's going to be 4 mole PCl3 to 6 mole Cl2. And I'm getting that from there. Now we just have to calculate it out. And I should have prepped, well, I actually did prep it, but it's on another page. Calculator. So 45.59 divided by 124 times 4. And this is 1.47 mole PCl3. And ooh, and an ad for hair products. That's going to be very useful. 130.5. I got a free app that I'm using, so I have to deal with ads. Times 4 divided by 6. And this is 1.23 moles PCl3. So that means that chlorine here is the limiting reagent. So we want excess. So we're going to do, we start with what we have, 45.59 grams P4. So minus 130.5 grams Cl2 times mole Cl2 to 70.9 grams Cl2 times mole P4 to 6 mole Cl2 times 124 grams P4 per mole P4. And I'm getting this dimensional analysis, this step here, from this ratio there. Okay. And you do all of that. And I'm just going to look up the answer. You do all that and you get 7.59 grams P4 left over. Okay, recap for this one because it's a little longer. So this is a limiting reagent problem. So we're given a certain amount. Oh, come on. There we go. So we have 145.59 grams P4 and 130.5 grams of dichlorine. And so P4 is about 124 grams per mole, chlorine is 70.9 grams per mole. And we start with this and then do dimensional analysis to see how much product we have. If we have the P4 all react, we get 1.47 moles. If the chlorine all react, we get 1.23 moles. So the chlorine is a limiting reagent, and then P4 is an excess. So then we start with the original amount of P4, and then we subtract how much P4 is going to be consumed with all the chlorine being used. And so you start with the mass of chlorine, convert to moles, convert from moles chlorine to moles, P4, convert to mass. So then you have the most mass separated minus from the amount of that's consumed, and you get 7.6-ish left over. Question, yeah.
Wouldn't that get you a negative number at the first step?
Which step?
Phosphorus minus the chlorine.
No? Did you do the math and it's a negative step?
45 minus 130 grams.
This times that
You
time.
do that first.
It's you do the multiplication before the addition and subtraction. Yeah, you wouldn't end up with negative 85 grams.
Yeah.
It's antimatter. No. Other questions? Okay. Formula metal trichloride, a 1.603 gram sample has 3.606 times 10 to the minus 2 moles of chlorine. What's the mass of the metal? So to do this, so first of all, we've got to figure out the molecular weight. Of MCl3, and the way you do this, it's because it's trichloride, so you take this number and you divide it by 3, but when you divide it by 3, that's the same thing. Well, because get the grams per mole. What I did when you're dividing the mole by 3, it's the same thing as multiplying. By 3. So the molecular weight is going to be 3 times 1.603 divided by 0.03606. What is that? 3 times 1.603 divided by 0.03606. And this is 133.4. And then now we have to subtract the chlorine. So 133.4 minus 3 times 79 or 70. I'm sorry, 35.45. I'm getting ahead of myself. mole, that answer minus 3 times 40, let's choose 35.45. And this equals 27.01, which means it's aluminum. So molecular weight of this is 27. The hard step here, because it's MCl3, it's you have to take this number here and divide it by 3. That's probably where people got messed up. And if you want instead, you could do 1.603 divided by 0.01202, and that'll give you the same answer. So, because this is the moles of chlorine, and there's 3 times as much chlorine as there are moles of the metal complex. Well, or I should say the entire formula unit. So that's I'm if I were to guess, I think that's where the step that people get confused. So, but does anybody have any questions with this? How to do it? You look confused, Andre. All right, I'll take a second. How about you, Zoomers? Do you have any questions?
No.
No? Okay. Can I go on, or you want to think more?
Well, you have a sample of an element or compound.
Yeah.
Then you get the molecular weight for chlorine. And then
You want the mass of the metal. What's the mass?
the mystery metal.
Yeah.
What is MW?
Molecular weight.
Is the molecular weight of the metal.
That's the molecular weight of the entire complex.
Okay, let me subtract the chlorine.
Yeah.
And then 3 times the sample.
All right, so if you have 0.03606 mole Cl, that means this means then so if you have 0.0303606 mole Cl, that implies you have 0.01202 moles of the metal trichloride, right? And then you take the mass, so the molecular weight is in grams per moles. So what you do is you take 1.603 grams MCl3 over 0.01202 moles metal trichloride. This means then that this is 133.4 grams MCl3 per mole MCl3. Do you see the units?
Yeah, it doesn't look like it says that in the equation, because it says 3 times 1.6. Oh, I see.
Because when you divide, 1 divided by 1/3 is the same thing as multiplying by 3.
Okay.
So I myself, I like to put as few steps in the calculator.
Yeah.
So I try to invert all my fractions and that kind of stuff. That's just my own, that's my own personal, like, call it preference. Other questions? Free to move on, because, and I don't mind spending a lot of time with the basic stuff here, because I mean, like, you've probably forgotten a lot of it. This is the beginning of the semester. So, all right. How many sig figs are in this one? So you have to multiply, just do the step by step. So you have 1.113 times 6.5. And you bring this to 4 sig figs. So it's going to be, because there's 4 sig figs here and 4 sig figs here. So you multiply this out and you get 7. Let me bring my pencil down smaller. You get 7.2345. And now, let's see here, you have 4 sig figs here. So you can only keep 4 sig figs. So this is going to then become 7.235. And now when you add then the 0.590, your answer, I mean, we could do this. This is going to be 7.725. But for addition and subtraction, you can go for all that are there. And so our this is your answer, and this has 4 sig figs. Do you guys see how that works, or do you have any questions? I guess you don't necessarily have to round it up here, but you have to keep in mind that there's only going to be that this answer only has 4 sig figs. Even though I've written 5, but you can only keep 4 of the 5 figures.
Even if you had a decimal that you're adding that was more.
Well, this operation there, the first step, the answer can only have 4 sig figs. Yeah, even if this had 12 sig figs, you would only, because of the first step there, you would only be able to keep 4 of them. Although don't stress too much about significant figures. There's only be like 1 or 2 questions on it. So, other questions? I'm losing Andre. Okay. Liquid octane reacts with oxygen, reacts with gaseous oxygen to form gaseous carbon dioxide and water vapor. So write the balanced chemical equation. So C8H18, and it's a liquid. So it says liquid octane plus O2 gas yields carbon dioxide plus water vapor. So that's what the just transcribing what's in words. You're going to balance it. So we've already put the phases. So let's balance it. 8 carbons here, 8 carbons there. So 18 here. Oop, what did I do? Went to the bottom, sorry. Back up. 18 hydrogens, so we can put a 9 in front of there. If we get our C, there's going to be a problem because we have an odd number. So 9 waters to balance the hydrogens. So let's look at the oxygens. So we have 16 oxygens here, and we have 9 oxygens there. So that means we have 25 oxygens. So that would mean 25 halves oxygen. Of course, that doesn't work out, so you have to multiply everything by 2. So multiply everything by 2. And you get 2, 25, 16, and 18. So I can copy this. Why write again when you can copy things? So the final answer would be 2, 25, 16, and 18. Like so. Questions on how to do this one? Is it too fast or just nice review? Okay, guess we got more to go through. Ooh, fun stuff. Hess's law. Okay. Use standard reaction enthalpies, determine the heat of reaction for this reaction. Okay, so what I do is I look at this equation, I look at these ones here, and I start out by writing them, which I will to see, well, I write them to put the reactants in the approximate right side. Sulfur is a reactant. So the first one I'm going to write sulfur plus O2 makes SO2, and this is minus H1. And then the other one, it's proper. The SO3 is a product. So I'm just going to go ahead and write that. 2SO2 plus O2 yields 2SO3, and this is just H2. So notice a few things. We have 4 here. So I'm going to multiply this one by 4. And we have 4SO2 and 2SO2. So this one we're going to multiply by 2. So 4, 2, 4. And now we can add them. So when we add them, what's going to happen? The 4 SO2s cancel, and 4 plus 2 equals 6. So we have 4S plus 6O2 makes 4 SO3, and I forgot about the 2 here. So, and that's of course what we want. And it's going to be minus 4 times H1 plus 2 times H2. And you just put in the numbers. So it's minus 4 times 296.8 plus 2 times minus 197.8. And whatever that is, I could put it in my calculator, but I'm not going to. Which one is this? This is chapter 2.1. Oh, yeah. And this is then going to be minus 1583, and it's kilojoules. Okay. So you see how to do the Hess's law? So here's your equation. You need 4 sulfurs plus 6 oxygens makes 4 SO3s. We're given sulfur dioxide decomposing and sulfur dioxide reacting with oxygen to form SO3. And the decomposition reaction, we flip it because sulfur is a reactant in the first one. So we flip the decomposition reaction, and you flip it, you put the negative in front of it, and then the combustion reaction, you keep it as is because the reactants and products are on the right side. The inverted decomposition reaction, you multiply by 4 because there's 4 sulfurs. The bottom one, you multiply by 2 to get the right number of SO3s. The SO2s go away when you add it, and the oxygens add to 6, and you get the equation you want. So it's minus 4 times the first heat of reaction plus 2 times the second heat of reaction, and you get negative 1583 kilojoules per mole reaction. So Questions with that? Okay, reducing agent in 2 potassium metals plus copper plus 2 acetate, making 2 potassium acetates and metallic copper. And the reducing agent, it's the one that it's oxidized. So if you look at the oxidation states, so it's a metal, it's a 0. This one is +2, because you see here the acetate that and potassium becomes +1. So 2 of those -1s. That means that copper is +2, and copper going is a metal is oxidation state of 0. So potassium is oxidized. Copper is reduced. And the reducing agent is the one that causes reduction. It's the one that's oxidized. The potassium metal, that's the reducing agent. So potassium solid is the reducing agent. Remember the reducing agent is the agent that causes reduction. It's the one that gives the electrons. It's the one that's oxidized. The oxidizing agent is the one that causes oxidation. It's the one that absorbs the electrons. It's the one that's reduced. So I know it's kind of opposite.
Yeah.
Yeah. So questions with this one? Think of being a womanizer or something. I guess that's for heteronormality. You know, the Britney Spears song, right? You're a womanizer. And, you know, I'm not a very good singer, but I think she's talking about a boyfriend. Yeah, right. I don't know. I don't even sing in the shower. I'm that bad. Baritone. Okay. Other questions? Besides my impending singing career?
I mean, so potassium's reducing because it's gaining an electron? Or
It's the reducing agent. It's being oxidized.
What?
Potassium metal is going to potassium +1, and it's being oxidized. And copper, it is being reduced.
And so potassium reduces copper.
Yeah, potassium causes the reduction.
Gotcha.
This is called the half reaction method. You learn about it next semester, but I'm just writing it out to spell out the point. You don't have to look at it that way if you don't want to.
That makes a lot of sense.
Yeah. Oxidized causes reduction. Reduced causes oxidation. Oxidation. Let's have a spelling contest. Oxidation. I would not do well again on the spelling bees.
I've lost my ability. I think it's the phones.
Oh yeah. Oh yeah. It's even worse when you have chemical names. Because like, I mean, like when you do like if you say something like dibromochlorofluoromethane, and you know, like it's just to be a big red squiggly line in that. Because even if you misspell it, like I always have to think phosphorus and fluorine still get me, like fluoride and phosphorus. I'm like, am I spelling this right? Put the U's in the right spot. The O's and the U's. Questions so far? So use the heat of formation, heat of reaction information provided to calculate heat of formation for iodine fluoride for if you know. So the delta H reaction, it's going to be the products minus reactants. It's going to be delta H 0F IF5 plus delta H 0F, or it's going to be 2 IF minus the quantity delta H 0F of IF7 plus the delta H 0F I2. And we don't know this one. This is our unknown, but we are given this. We are given this. We are given that, and we're given this. So you just solve for your unknown. Actually, maybe I'll just, I can do math via, it's kind of fun to do math this way. So you can move this over here. Oops. So plus minus that equals this. Of course, there's a 2. So you can divide the whole thing by 2. 2. And that's that. So you just plug in the number, you just put in the numbers then. So minus 89 plus a minus 941 plus 62.42 minus a minus 840 divided by 2, and whatever that is. What is that? Is this one? Oh no, it's not that one. You put all that in and you get negative 63.8. So, questions of that one?
The first equation is final minus initial.
Yeah, products minus reactants. Yeah. Yeah, you can look at it final minus initial. That's good. Products are final, reactants are initial. Like, you're all students initially, and then you're going to be honored graduates finally.
Okay, Starbucks.
Well, maybe if you win the lottery and you just want to do something, you can work at Starbucks, you know, hey, that's fine. I got $100 million, but you know, I like giving people coffee. Yeah, I love the smell of it all day. I just want to live here.
My grandma wouldn't understand that.
What are you doing?
Go to law school.
So it's a lot of reading. Oh man. You ever taken a legal class? That's a lot of reading. Anyways, other questions? Okay, let me see. That's another. I'm going to jump ahead to this one because this is just more Hess law stuff. Um,
Are they doing it in dynamic questions?
I just picked the ones that people did the worst on.
Those people that were saying it.
Yeah. I got 6 minutes left. Yeah. So mixing the reaction for mixing potassium iodide and lead acetate. So you have Ki plus Pb acetate CH3COO2 lead acetate. And so you gotta look to see these are gonna mix. And you're gonna get potassium acetate plus, what's gonna be 2. You don't have to balance it, but I'm just balancing because I just, in PB I2. And the question is, what are the states on this? So actually, no, I shouldn't go there. What is it? Chapter 5. No, it's 4. Where's it, chapter 5?
It's like,
Yeah, here it is. Oh, good. So if you see here, so you start off with potassium. You can't see that. Potassium, no exceptions. Acetate, no exceptions. You have the iodine and lead. Lead is an exception. So that means that PbI2 is a precipitate. So it's a solid. So so that means that you're going to get the states here. You're going to get 2 potassium acetate plus PbI2 solid. So this is going to drop down and you have a precipitate from that. So it's not no reaction. You get a lead iodide precipitate. So do you see how to use the chart? I can go back to the chart. So
most transition metals are into precipitates.
they tend to be more insoluble. The alkalis are very soluble. Like generally speaking, like alkali is very, very soluble. Alkaline earths, a little less soluble, but generally are fairly soluble. Transition metals tend to be pretty insoluble, but like halides tend to be very soluble. So like iron trichloride, for instance, is soluble. But you can see that silver, mercury, and lead chlorides are insoluble. But I mean, any random elements, I don't know, titanium chloride, that's going to be soluble. You know, kind of thing. Other questions? Of course, the bottom part is insoluble, generally speaking. Those are the trends. Yeah, sulfates tend to be pretty soluble because you throw a lot of things, because sulfuric acid eats a lot of things. Forms metal sulfates. Like in lead car batteries, you have sulfuric acid, and actually that's part of the lead sulfate is actually insoluble. So you get the nice thing is you get the formation of the precipitate, but you can turn it the other way. But anyways, other questions?
Something at the end of chapter 11.
Okay.
It's just the chart for like the molecular orbital diagram. At the end of chapter 11, it talks about doing it with
You know, polyatomics not on there. Or
or like,
heteronuclear?
yeah, and like figure, because it only shows us what it is.
Or homonuclear?
Yeah, will we have to know what the charts are?
Heteronuclear? No. Heteronuclear is not on there. Hetero mean different. Homonuclear, same nucleus, yes. But I mean, if you have the chart, you have the book in front of you and you have the notes.
We don't know if it's para or diet, but I mean, it's kind of.
You do that you can. That's a fair question. No, but she's asking heteronuclear. So like nitrogen monoxide, that's heteronuclear, different. So different nucleus.
Right.
O2 is homonuclear. So yeah, you have to know this, but not that.
Because I just got confused with that one. They kind of just pulled the diagram. of the position.
Yeah, they calculate it out. That's above and beyond the class.
The homo one's easier, right?
Yeah, considerably.
This is symmetric.
Yeah, because it's very, very symmetric, yes. Where the hetero is asymmetric. Zoomers, any questions? I know we're over, but you know, I got nothing to do. My life is just all about chemistry.
You want to trade lives? Got a very exciting life.
I'm good.
There are some aspects of your life that are exciting. I'm rather comfortable where I'm at, though. All right,
Thank you.
Thanks for the review session.
hopefully I'll see you. I don't know. Maybe I'll see you on Zoom.
See you on Zoom.
Yeah.
Thank you.
You're welcome.
Yep.
Goodbye.